Hello there, I'm Thomas Hatsios, the German American pilot flying the Boeing 787-900 tonight flight. We're going to be overflying Zurich, Switzerland, Germany. Then coming back to Zurich International Airport, runway 14 for an Lszh localizer landing zone. And I am in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 jet aircraft and Microsoft Flight Simulator X. I'm going to start showing you the cockpit instrument displays and the functions of the Boeing 787-900 jet aircraft. The primary flight display that displays the airspace indicated, the airspace selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric pressure of the outside atmosphere, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the vertical rate of climb in the center of the aircraft in 10,000 feet per minute. All the stiffness of the trigonometric angles in decrease in incline and descent. We have also the artificial horizon with the altitude indicator, the pitch ladder decrease and the bank angle in decrease, the Ilsloc localizer, the horizontal localizer, and the vertical glide slope. We have the radio frequencies at the ends of the threshold of the runway we use for takeoff and for landing, and the onboard at the ends of the aircraft that receives the radio frequency and calculate the horizontal and vertical deviation from the runway as we approach for landing or we are in takeoff. So we have the Zurich International Airport, the Lszh and runway 14, both for takeoff and for landing. So you're gonna see that the Lszh Zurich International Airport in Switzerland. We have also the HSI, the horizontal situation indicator with the magnetic heading and track. Also the integrated display with the flight plan. We're gonna create a flight plan using the flight management computer. So we have the navigation display to display that. We have the magnetic heading and track, the magnetic north pole, and the geographic north pole, and the magnetic variation depending on where we are in the world. You can see the horizontal and vertical profile of the terrain around you using the weather radar. We have the terrain also reflections. You can see with red, green, and yellow reflections, and also the blue for the lakes, the rivers, and the sea. You can see also the terrain map with the airports, the airport names, the four-letter names of each airport, where it's located. You can change the distance, the nautical miles, the range. So you can have also in each airport the runways we use for takeoff and for landing. We have also other aircraft that fly around our aircraft are displayed using the DSP and ADC transmitter receiver that transmits our frequency to other aircraft, and the air traffic control and receives from other aircraft and calculates from the computer the other aircraft distance from our aircraft, the altitude difference as we fly from our aircraft, whether they climb or descend with respect to our aircraft. Also, it can calculate the velocity difference between our aircraft and the other aircraft, so the velocity closing in. So we have an incoming collision. It will give us, using the TICA system, the traffic collision advisory system, will display the other aircraft advisor. We have to make an evasive maneuver in the air. So we have also the display of the navigation aids. You can see the voice stations, ADFs, and the airports. As I told you, the waypoints which are horizontal vertical navigation fixes. We have to fly through. As we fly, we're gonna select some waypoints, and the aircraft we're gonna have to fly through. Either manually or automatically, we're gonna have to fly through using the flight management computer. We're gonna create a flight plan or a flight path or a route. You'll see the purple or magenta line legs from each waypoint to the next one. From takeoff, from the departure runway, we're gonna use in the airport that we are located right now, the Zurich International Airport, the Lszh in Switzerland, and we're gonna select the runway 14 and back after making a few turns in the air back to the same airport. So we're gonna create a flight plan or a flight path or a route. You will see how we're gonna use the flight management computer. I will input all the data of the aircraft for this flight. That includes the takeoff gross weight, the empty weight plus the passenger plus the cargo plus the fuel on board, the reserve fuel, the tax fuel, and the trip fuel. The flight management computer is going to calculate where the fuel is from the left and the right wing in the center tank, how much we have it, 30% in the left and right wing, 30% in the left wing, 30% in the right wing, and 10% in the center tank. So give us the center of gravity and the minor dynamic core position of the forward wings in terms of the forward wings of the center of gravity is 23% of the Mach. This is the position with the maximum dynamic lift to cruise in the forward wings. Is also the position where the stall, the airflow becomes detached from the top surface of the wings as we fly. So this also is going to be displayed. We have to monitor the stall speed here as we fly. You can see the stall speed in the primary flight display. You can see the airspeed indicated. The stall speed is going to be given with a yellow and with an amber and red indication over here. We have other indications: the airspeed selected from the autopilot, the altitude selected from the autopilot, flight director system panel, barometric altitude 1430 feet. Here's the vertical rate of climb descent of the aircraft in tens, hundreds and thousands of feet per minute, or the steepness of the trigonometric angles in degrees can climb and descend. So you have also the artificial horizon, the indicator with the pitch ladder degrees 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees for pitch up or pitch down. Angles, the radio altitude above the ground 2 feet, the radio minimums, and the barometric pressure of the outside atmosphere is 29.92 inches of mercury. So you can see here we have the barometric pressure for the barometric altitude setting. I'm gonna show you how to use that also. So we have also the angle as the aircraft flies, the bank angle. You have to pay attention both to the airspeed, the pitch attitude in flight might be positive, but the aircraft might be falling instead. So you have to pay attention to all indicators, the airspeed, the altitude tape, and the vertical rate of vertical speed indicator, and also the altitude indicator, the flight mode annunciator with the autopilot and the autothrottle, ledger vertical navigation modes. You can see the same values here, 200 knots, the airspeed indicated, the airspeed selected over here, 200 knots. We have the autopilot engage and disengage switch, the LNAV, the VNAV, which is gonna be connected from the flight management computer. Flight level change, this knob changes the airspeed. Climb continues, auto throttle arm, left to right, flight director, heading here, bank angle and heading guidance, hold, vertical rate of climb descent of the aircraft 10 feet per minute, the altitude select knob, barometric altitude above the sea level. So we're gonna have all these indications, all the functions of the aircraft of the Boeing 787. You will see also, as I told you, primary flight display, HSI. You can see the heading selected 360 degrees here. We have the terrain map here, the terrain weather reflections, horizontal, vertical. Over here, the aviation, you can see how far above the ground the aircraft will be flying here. With this indication, you can see the aircraft symbol, this triangle, as we're going to be flying higher altitudes above the ground. You'll see the terrain in front of you, the airport that we are located. Also, the FS panel here, you set the range and the modes of the display. Also, you can set weather radar, traffic, terrain on the display. We have systems also over here, CDU info, checklist, communications, and the barometric pressure for the altitude in inches of mercury, hectopascals, radio minimums, cancel, accept or reject warning over here. So we have a few more things to see. You will see also the engines and the flight controls of the Boeing 787, how to use the flight control system. You can see the engines indications here, the left and the right engine. I will talk to you later. The landing gear, the flight management computer. We're gonna use flight management computer here to set up the flight plan of the aircraft for this flight. You're gonna see also the mouse pad here using the cursor of the displays. We have the fuel control over here, left and right engine, fuel flow, thrust levers, forward and aft of the engines, and auto throttle, disconnect, flaps, position and speed brakes, radio management panel over here, navigation radios, parking brakes, pitch trims. So you will see horizontal trim stabilizer, also the horizontal trim stabilizer of the aircraft of the Boeing 787. The horizontal trim stabilizer, as we fly, we have to trim the horizontal tail of the aircraft. So you will see how we're gonna do also that. Trim the horizontal tail of the Boeing 787 as we fly. I will use the flight management computer as I show you. Tells you we input the takeoff gross weight. The flight management computer is going to calculate the left and the right wing fuel tank, the center tank, the loads from the passengers and the cargo. It's going to calculate the center of gravity for takeoff, and after takeoff, as we fly, we burn fuel. The center of gravity is shifted, it is calculated every second from the flight management computer. That gives also the flight control computers, the autopilot flight director system panel, and the auto throttle commands. So we have for the LNAV and the VNAV, you will see the left and the right wing, the mean aerodynamic chord position, as I told you, the Mach 23% of the aerodynamic chord of the forward wings of the aircraft, is also where the stall begins and the maximum aerodynamic lift occurs. We're gonna select the runway for takeoff in this airport, the Lszh, Zurich International Airport in Switzerland. We're gonna select the runway 14, both for takeoff and for landing. The runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air, and also other data, the wind direction and speed, the temperature of the air, whether the runway is dry or ice or wet, and it's gonna give us also for the flaps we're gonna use for takeoff. We're gonna use 15 degrees for flap. It's gonna give us the takeoff speeds, the V1, V rotate, and the V2. We're gonna have V rotate and V2 about 140 knots. V2 plus 15 knots is gonna be like 155 knots with a pitch attitude of 9 degrees. We're gonna rotate the aircraft at about 9 degrees in takeoff. So you will see how we do that, how we take using the flight controls, the yoke of the Boeing 787. We're gonna pitch trim also the aircraft in flight. We're gonna see also that. So we insert also the seats. The seats are the standard instrument departure waypoints and fixes that include the initial horizontal and vertical navigation fixes of the aircraft for the initial climb. We're gonna climb to the cruise level, like 35, 36, 27, 29, 30,000 feet above the sea level. We're gonna cross through some waypoints. We're gonna select from the flight management computer. There we have the top of descent. After we make a couple of turns here, we're gonna descend back to the airport from the cruise level at 28, 29,000 feet back to 6 or 7,000 feet above the sea level. We're gonna have the stars. The stars are the standard terminal arrival waypoints and fixes for the terminal approach and landing of the aircraft, for the alignment of the aircraft with the runway. We're gonna use again the magnetic north pole heading of 136 degrees for the approach and landing, and the Ilsloc localizer, the instrument landing system for the terminal approach and landing to the airport runway. I'm gonna have the horizontal and vertical navigation. Yes, and the instrument landing system, the Ilsloc localizer. I'm gonna show you how to change either manually or automatically using the radio management panel and also the flight management computer. So we're gonna have the horizontal vertical approach and landing. It's gonna receive the radio frequency transmitted from the threshold antennas of the runways. You can see here. So it's gonna be aligned as horizontally and vertically. I'm gonna talk to you also about Newton's physics, aerospace, and aeronautical engineering. We here derive some principles about the aircraft before flying. We need also for the air transport pilot license. So for the air transport pilot license, we need these things. So you can see here the aircraft wings hold the weight of the aircraft as it flies. You can see the thrust from the engine moves the aircraft forward, the propulsion from the engines. You can see we have the mean aerodynamic chord position. I told you is where the maximum aerodynamic lift occurs. The wings are about approximately here. 23% of the Mach is where the maximum aerodynamic lift occurs. In the forward wings is also the position where the stall, the airflow becomes detached from the top surface of the wings as we fly. So we have the deflection from the flight controls over here of the airflows. So you can climb and descend, you can make turns in the air, turns to the right, turns to the left, through around the longitudinal axis. You make the bank rolls. This is the longitudinal axis, transverses the vertical. Around the vertical you make using the rudder pedals. You have the yawing turns. Through around the lateral, from wingtip to wingtip, you have the pitch attitude. From the horizontal tail you climb, descend the aircraft like this. So we have, as I told you, the aerodynamics of the aircraft. The center of gravity pretty much here is also, you can see the longitudinal axis from nose to tail also affects the horizontal trim stabilizer. In flight you can trim either the whole tail up and down, left and right, or the elevator surface. This is the elevator for climb descent. So you will see the flight controls. You can see also the wings here, using the Bernoulli fluids over here. The bottom surface of the wings is more flat, so the airflow using the Bernoulli fluids, and we have the curvature from the flaps extended. Also, we're gonna have an angle of attack like this in flight, maybe. So the airflow is gonna be moving much lower below the wings. So this is gonna give us higher pressure. It's gonna pressurize the aircraft wings up into the air with the weight of the aircraft. You can see also, so we have higher pressure below the wings and lower pressure above. You can see the top surface of the wings is more curved, so we have higher airflow as we're gonna be flying faster actually. So there is lower pressure above the wings, which sucks the aircraft wings and weight up into the air. So this is the main components of the explanation of the flight control system. Maybe I'll show you the flight controls now. And the systems inside. Set up the flight management computer over here for the flight plan. Then show you the overhead panel. Over here, electric, hydraulic, fuel system, pressurizer. You're gonna see all the systems one by one. It's too many. Also start the engines, the APU and the engine starters. I'm gonna make an engine start demonstration just before flying the aircraft. So you will see also that. So gonna be having to fly the aircraft like this, the flight controls. So I will talk to you about the flight controls now. How you use the yoke to control the horizontal tail of the aircraft for climb descent. Also the ailerons, the spoilers and the flappers. Use the control wheel to make left and right turns, bank rolls in the flight. We have also the horizontal trim stabilizer. We can trim the horizontal tail of the aircraft as we fly. We can use also the rudder pedals for nose steering, for controlling the yaw, the vertical tail, the rudder in flight, and also for toe brakes. And we have also the thrust levers, the flaps and the slats, the speed brakes, which are secondary flight controls. So you'll see how we control these things right here with the side stick. I have the Lszh Extreme 3D for this function of the Boeing 787. The yoke over here we control using the side stick. You can see we can climb and we can descend. We have the vertical column of the yoke for climb descent. Also make turns to the right and to the left. We have the control wheel, this section over here. You see it moves only its own. If we need, we can move all together. Also the rudder pedals for using the vertical tail, the rudder over here, and also the nose wheel steering the ground on the tiller to move around using the nose wheel of the aircraft. So you can see both sides are interconnected and move together in flight. The captain and the first officer, unless we have a failure. It's not like the Airbus, you have the side stick priority from either side. Also you have, as you can see, over here we're gonna see also the outside view. So I'm gonna show you now the outside view of the Boeing 787 also, the flight controls. So you will see also this hard control for climb descent, the elevator, also the rudder pedals over here. You can see the rudder is moving. You can see the elevator here for climb descent. so you can pick up what you want, the ailerons and the spoilers in the left and right wing, and the flaps extended or retract. Σε περίπου μισή ώρα περίπου. Γιατί βιάζεσαι?
Όχι, θα ήθελα, εγώ βασικά δεν είχα άλλο μαζί μου πάνω λεφτά και δεν πήρα τα ψωμάκια το γρήγορα για τη δουλειά. Εδώ στο...
Θα πάω να τα πάρω εγώ μόλις τελειώσω.
Θα το πάρεις σήμερα?
Ναι, εντάξει, μη φοβάσαι. Ναι, okay. So you can see here, the flight controls, the control column, climb, descent. Let's make turns left and right. The rudder pedals, nozzle steering, the vertical rudder. So we have, also I'm gonna show you another view of the Boeing 787 flight controls. You will see this is better view, I believe. Also you're gonna see again the outside view of the Boeing 787. So you can see here. So you can see we can climb and we can descend like this. So this is the climb. The tail, the horizontal tail of the aircraft, the horizontal stabilizer for climb and descent. Also make turns to the left, make turns to the right. Control wheel like this. So make turns to the right, make turns to the left. The rudder pedals, you can use all flight controls together, coordinated flight. So I hope you like the jet aircraft. Also the thrust levers, I forgot to mention the jet engines of the aircraft. You can use forward and aft thrust over here. All the flaps and the slots, the speed brakes. Horizontal trim stabilizer, the horizontal tail of the aircraft. So you can see here also the outside view. Again, climb and descent. Make turns to the left and make turns to the right. You use the spoilers also for making turns right and left. The elevator, descend, climb. You see the elevator. So maybe you see also ailerons and spoilers like this. Left and right turns. So this is all for the flight controls of the Boeing 787. As you can see, for climb and descent, make turns to the right, make turns to the left. I hope you like the side stick. We can leave neutral also, as you can see. The side stick for the Airbus also used for the Boeing, no problem for that. So we have the control of the aircraft like this. So we have also a few more things how to note. All the systems. So about 30 more minutes. So I'm gonna show you also that the outside view over here. So we're gonna set up the flight management computer now. We're gonna talk about the engine horizontal trim stabilizer. Also I forgot to mention, you see these train seats here. We have the horizontal tail of the aircraft, which is kind of part of the flight controls. So this way you pitch the nose down as you fly. This way you pitch up the nose by moving the horizontal elevator trim left blink right, some aircraft is the whole tail surface. So this is how you trim up and down, moving these suites. You have also the autopilot disconnect and head-up declutter. So you see autopilot disconnect over here, elevator trim left and right, head declutter. So also you have, since this is a fly-by-wire aircraft, you have the autopilot flight director system panel. You have the auto trim function. Since this is a fly-by-wire aircraft, as you fly, you can trim either manually using horizontal trim stabilizer. You can set up flight management up here. The autopilot flight director system panel, the auto throttle will trim itself using the flight control computers, and the flight management computer input maybe. So if you have a failure of L2 and R2 hydraulic systems, you can see the hydraulics here that affects the horizontal tail trim stabilizer. You can see stabilizer L2 and R2. You have to open this guarded switch here. You see elevator cutoff, and from normal to cutoff for Boeing 737, 747, 757, 767, 777, 787, from normal to cutoff, you will disconnect the auto trim function from the aircraft. Then you will have only the manual trim function for the horizontal elevator or the horizontal stabilizer. So you have here also normal and alternate pitch trim. So this is the alternate pitch trim of the aircraft. You can use this channel to trim the horizontal tail of the aircraft. You have the parking brakes also. You can see the radio management panel, the radios. So we have the fire extinguisher for the left and the right engine also. The transporter over here, the rudder trim over here, radio management panel. I will show you the fuel control and the engines now. After I will show you. So this is to trim the horizontal tail of the aircraft as you fly. You see the horizontal tail moving up and down. The elevator also. So trimming gives a better effect in flight. You can leave the aircraft with hands off as you fly. You have enough thrust and altitude that is good enough with the pitch trim set correctly. So you can see also, as I told you, you have the flaps over here, how many degrees. You can retract over here to 0, 1, 5, 10, 15, 18, 20, 25 over here. You can see 25 and 30 degrees. You have the speed brakes also over here. Retract and extend. You can see the speed brakes extended and the flaps are extended also over here, both sides. We have the thrust levers or the throttle over here. Disconnect switch, take off ground. This disconnects the auto throttle. These switch over here. If you press auto throttle, disconnect. This is take off ground, thrust reverse. Also, I will show you a couple more things to know. The flight management computer, we're gonna set up the flight plan of the aircraft before flight. So we'll set up the flight management computer with all the data we need. So you will see how we're gonna do that now. So you see another view here of the pedestal, the controls, the aircraft. So you will set up, we're gonna set up the flight management computer, the FMC, for this flight. So you will see here we have the index that initializes. It has the main functions: identity, position, performance. Over here, takeoff, approach, navigation data, flight plans, load ATC, load plan, save plan. So you have identity, Boeing 787-900, GNX jet engines, the AIRAC cycle, position, reference airport, Lszh in Switzerland, the GPS position, inertial reference coordinates, nearest. We have the index again, performance. We're gonna set after we set the initial data of the aircraft. So we set the route, origin, and destination. So this is origin Lszh airport, back to Lszh, copy paste. Runway 14, set the runway 14. This is the route. We set the departure over here. We can select either runway 10, 14, 16, 28, 32. So we select runway for takeoff 14. And the seats, the southern into the departure waypoints and fixes Zui to Alpha. So we're gonna select departures and arrivals here. Select the arrivals from the index. So you can select either approach VOR 16, VOM 28, ILS 14, ILS 16. Also we have GLS navigation 14, ILS 34, ILS localizer 28. So we're gonna select ILS 14, ILS localizer, trans Amiki, trans maybe Negria 1 alpha. So we select this. We will select GLS in next flight actually and see the difference what the GLS system makes. So we have the index, the route, departure, arrivals. Here is complete for the selected airport that we are located. We have the flight plan now. It's ready, created, but not yet completely formatted. We need to cancel discontinuity, a double waypoint. We have from takeoff, climb, cruise, descent, approach, and landing. Over here you will see the distance from each waypoint to the next one, the altitude we have to cross through. So we set the zero fuel weight plus fuel on board in thousands of pounds, 332 plus 34, 357,000 pounds. The reserves 5%. The cruising altitude 25,300 feet. Cruising altitude here, and cost index 100%. The fuel freezing temperature, the fuel is gonna be freezing as we fly at minus 37 degrees. So the aircraft recirculates automatically using the FAREX. So we execute, and we have the purple. We have cruising center of gravity also. Indication here 135 degrees. First heading from takeoff 2 nautical miles away from the runway threshold. As we're gonna take off 250 knots, 1900 TRO 96. 1 nautical miles, 3,290 feet, 095 heading, 3 nautical miles, 250 knots, 2,500 alpha. Then as we climb Zui, we change direction again. We make a left turn here for the Zui intercept waypoint. So we have the waypoints, the stars displayed in the navigation display. Use later 302 knots, 6,000 alpha. We keep climbing to the Negria. Is change a little bit direction again to 86 nautical miles away from Zui. 302 knots, flight level 22,100. Matif, we start the descent 12 nautical miles away. 320 knots, 11,800. Amiki 258 degrees. Here we make a right turn after Negria for the Matif. So we change direction again. We follow Amiki 6 nautical miles from Matif, 190 knots, 10,400. Zui 276 degrees, 9 nautical miles, 108 knots, 7,000 alpha. We have the stars here, the southern terminal arrival waypoints. Fixes the 8701, 108 knots, 6,000 alpha. TRA 108 knots, 5,000 alpha. Here is the terminal approach and landing. CI14 108 knots, 4,000 alpha. Also name 170 knots, 4,000. Runway 14 140 knots, 1,455 feet. So we have the complete flight plan. Also takeoff, go around. We need initialize performance. 15 degrees of flaps here. Center of gravity. Trim 33% and 4.25 degrees horizontal trim. Stabilizer for takeoff speeds V1, V rotate 130, V2 140, gross weight and runway position. So this is the complete flight plan or flight path or route. You'll see it displayed with a purple line in the navigation display. We have departure, arrivals, alternate, VNAV, progress, FMC communications, hold. You can select something, waypoint to hold in flight, fixes, set a fix, and radio navigation also. So how to use the flight management computer of the Boeing 787 Z aircraft. So you will see all the data we need. A few more things to do before flight here. The Boeing 787. So we set up the flight management computer over here. We have the flight plan. You can see. We will see also the runway that we are located, displayed in the GPS also display. So you will see how we achieve also that. Also here, so you will see the navigation display now a little bit different. The things displayed here in the head-up display before flight. You can see the flight plan. We have created this purple line as we're going to be takeoff, climb, cruise, descent, approach, and landing. We have the fixes or waypoints, the intercept over here. You can see also an empty array. This is the approach and landing part. I'm going to have the takeoff here. You see it's contested a little bit. Display. You can see also the vertical flight path, how we're gonna climb over here this purple line, cruise about 25, 23 and 30,000 feet, then approach and landing we can fly higher, even 40,000 feet. So you can see also the airports here is Germany, France and Switzerland. You can select other locations here. You can see how far away we're gonna be flying or closer. You will see a better view of the flight plan. You can see also the terrain below you as you fly. You see the yellow and the green indication from the radar scout. In front of you, you will see something like this, some terrain. So you need to follow both horizontal and vertical profile flight. You can see also the runway here where we are located. As I told you, the runway we're gonna use for takeoff, the taxiway in front of us, and the other runway. If you look in front and around you, you can see here as displayed in the GPS and the terrain also. So we're gonna have all this data here. You can follow the flight plan from takeoff, climb, cruise, descent, approach, and landing of the aircraft. So you can see all the stars here. As I told you, intercept from takeoff the runway. We're gonna make a left turn, then another couple of turns, then approach and landing here. The elevation of the terrain 3000, 1600 for this range. Also the plan also display over here. You can see a few more map scenery over here. The terrain, the elevation for this distance from takeoff, climb, cruise, descent, approach, and landing. Set up a little bit more further distance. You will see the waypoints we have to cross through. The Negria, Mati, Famiki, Zui over here. So this is from takeoff, climb. Over here, cruise, descent, approach, and landing. Further away, more airports. Closer, you will see a better view. This contest is also gonna display in the other side, display later. So we have this for navigation purposes. All the data you see here from the pitot static and pitot dynamic, the airspeed, the altitude, the rate of climb descent, the laser gyroscopes for the laser gyroscopic acceleration, deceleration, magnetic north pole and geographic north pole, inertial navigation, GPS receivers. So all are contained in this air data computer. Here you see heading reference. It also contains the airspeed and air data computer for the airspeed and the altitude calculations, radio altitude, angle of attack of the aircraft as it flies through the airflow. This also sensor temperatures and also laser gyroscope. So this a few of the functions you can have from this your data computer. All these displays very important. Feeds other parts of the computer to power director system panel. So also the engines indications in the left and the right ACAS and indication across the system display. We have the left and the right. We have the Gen X engines installed in our Boeing 787-900 aircraft, one in the left wing and one in the right wing. For symmetrical thrust and redundancy, each one contains a gearbox with the FADEX. The FADEX are the full authority digital electronic control computers. One installed per engine gearbox, dual tunnel redundancy, one tunnel phase, the other takes over controls displays of the engine direction in the upper and lower ACAS or in the multifunction display like the N1. The N1 is the low speed south low pressure compressor and turbine of the turbofan which is engine, the exhaust gas temperature engine, the N2 which is the high speed south the high pressure compressor and turbine of the turbofan which is engine, the fuel flow per inch per 1,000 kilograms of pounds, oil pressure, oil temperature, quantity and vibration of the N2 stage of the engine. Also controls the outflow valves, I will show you later in the display also, of the pressurizer from the 5th and 9th stage of the engine and from the front fan stage from the bypass. So it can supply other systems that need pressurizer like the cabin pressurization system as we climate and the aircraft will pressurize. Also we need the oxygen regulation in the cockpit and the cabin, and also air conditioning ventilation, wing and engine on the ice, and also the hydraulic fluid tanks pressurization are pressurized from the engine's pressurizer outflow valves. So I'll show you the displays of that. Also you can see here the hydraulic pumps here that are pressurized. It's we have the primary demand hydraulic pumps, and also the tanks are pressurized for air from the engine. We have also the pressurization here panel. We have the APU, also the auxiliary power unit, a smaller turbine in the tail of the aircraft. We need to start the engines later. Also you can supply with pressurizer for the start of the engines, also the backup amplifier. So when we move the flight control, so you can see we have flight control computers. It's electrically controlled fly-by-wire system like the Airbus, but it has also hydraulic actuators to move the hydraulic flight controls around, like the tail, climb descent, the ailerons, the spoilers, the rudder. Also the landing gear, extend and retract, needs hydraulic pressure, rudder pedals, all flight controls, nose steering, thrust reversers for the engine flaps, speed brakes, parking brakes. So you see the flight controls move with hydraulic power from the engines. We need also pressurizer, as I told you. The FADEX, also the full authority digital electronic control computers. These are electronic control computers of control. As I told you, over pressure and under pressure inside the engine, they can open and close the outflow valves in higher or lower position. They can control also the fuel metering unit, engine start, engine shutdown, engine failures. Also, as we fly the aircraft in higher altitudes, we have freezing temperatures. Most jet aircrafts, they have the recirculation system from the left and the right wing tank and the center tank to the engines components. This is controlled automatically from the FADEX to heat up the fuel by ducting heat from the engine components and cooling down the engines. Also, we do the same for the lubricant and the oil. As we fly, it's automatic the fuel recirculation system. So you can monitor here the temperature of the fuel. Also later I will show you in the displays. So you see also we have the outflow valves position, the cabin pressurization, climb descent, cabin altitude, rate of climb descent, differential pressure 1400, rate and landing altitude, gross weight for takeoff 1000 pounds, total fuel temperature over here minus 3 degrees right now. So you see the warnings also for the outflow valves over here that we open. So we have the N1, which is the low speed starter sub low pressure compressor into one of the turbofan tubes engine left and right, the exhaust gas temperature per engine, the idle setting, takeoff, gross weight, maximum thrust, green, yellow, and red. N2, which is the high speed starter sub the high pressure compressor into one of the turbofan tubes engine, fuel flow per inch per 1,000 kilograms, 1,000 pounds, oil pressure, oil temperature, oil quantity and the vibration of the N2 states of the engine. Also the fatigue as we fly higher from takeoff from the sea level or the airport elevation, as we climb higher to like 20, 30 or 40,000 feet above the sea level, like 8,000, 9,000, 10,000, 11,000, 12,000 meters above the sea level. As we climb higher, the density of the air, the pressure and the oxygen level of the air become less than half than that of the sea level. Also the aircraft will be flying with an airspeed rate like 2 or 3 times faster than that of the sea level. Also we're going to be having, because of that, higher intake of air from the front fans for combustion and compression. We have also lower temperature. The temperature is freezing, minus 30, minus 40, minus 50, minus 60 degrees below zero. So we're going to be having a different fuel mixture request every second. This is also adjusted by the fatigue. Also, as we descend back to the airport elevation, it's a good thing to have the fatigue installed into your engines. Now we'll show you also how to make the engine start demonstration. We're gonna start over here the APU. You can see the electric left and right generators, 120 200 volts, the APU, the battery. So this 120 200 volts, 400 Hz frequency, 120,000 kilowatts left and right engine driving, primary flight control computers at auto position, heading reference, flight control surfaces, over here towing power, FD door over here, passenger oxygen over here, window heat, rammer turbine backup hydraulics. So we have, if we turn off the hydraulic pumps, you will see what happened. The fault comes up. So we reset back to the on hydraulic power pressure for the left and right engine. We have also lighting system and windshield wipers. You can see over here we have the recorders on cargo and APU fire, electronic edge control for the engine, left and right engine, auto start also, and normal and arc name board for the engine control. Fuel jettison, you can dump some fuel in flight, lose some weight and select the nozzles if you are on this, and how much fuel to remain. You have the fuel left and right, wing fuel tank, setter pump, crossfeed valve, balance. If you use the crossfeed, you can feed either engine with other pump or either tank and balance the fuel between the left and right wing. So you have the fuel booster pumps, wing and engine RDIs over here, on and auto. Also we have the packs from the left and the right engine, from the APU, the pressurization, also pressurizer and pressurization, climb descent, in manual or in auto you have to do nothing, it's all automatic. So we have one last thing to see here. You can see everything we see in the overhead panel in digital format right now very quickly. So you see all the systems. You see over here we have the hydraulics, APU, oxygen, liquid cooling. Over here you can see the systems, what's going on. As you can see with better, more clear view. We have the electric also, left and right engine driving IDG. The APU is running, the battery voltage here, 120 to 100 volts, 400 Hz frequency, 120,000 kilovolts, main battery 31 volts, the average load set. We have the hydraulics, where the hydraulic fluid goes, which systems use hydraulic power pressure, primary demand, electric C1 and C2, 5100 psi, each system, and the quantity of the hydraulic fluid, fuel, left and right wing fuel tank, center tank, low and high pressure fuel valves left and right engine are open and feed both engines from the center tank or from the wing tanks. You can see 11,000, 11,000 and 11,000 pounds, total fuel on board 34,100 pounds. The crossfeed valve is off, but we turn it on. We can feed either engine with either pump or either tank. APU is fed from the left wing using the DC motor. We have also the minimum fuel temperature here, minus 37 degrees, below which the fuel will freeze in flight, so we need to heat the fuel in flight all the time. You can see the fuel temperature right now, so we use the recirculation of fuel. The air pressurizer from the packs, left and right engine and APU. The doors are closed, the cabin can be pressurized, the gear, you can see the pressure of the tires and the temperature of the brakes, flight controls, the nose will also, flight controls. Here again, one more time, so you see all flight controls are moving accordingly. There is no malfunction. So you see also the tail here, the vertical and the horizontal tail, the rudder pedals, the horizontal trim stabilizer. F is display maintenance. Over here, digital and circuit breakers also. So we have one last thing here, the checklist before doing the engine start, normal menu, and also communication. So before start, before takeoff, after takeoff, descent, approach, and landing. So we'll go back for doing the engine start demonstration here. Turn on also the lights. So we're gonna turn off the engines now. As you're gonna see, both engines, fuel control to the off position. You would see left and right engine to the off, engine power is decreasing. So we're gonna start the engines now. We need the power from the auto start system. Over here, auto start both switches to the on. As you can see the yellow reconfiguration in the top. So we have fuel pumps indications here. Above 20%, we have enough pressurizer. You can see the hydraulics are coming back live. So we need only to start the fuel control over here, left and right engine. So we start the fuel control like this. We have the auto start, both left and right engine. We need a couple of minutes to start the aircraft. So to start 49, 50%, 53, 55, we're gonna be having the engines ready for takeoff. As you can see, 62%, both engines are running. We can go for takeoff. We need only one last thing, the autopilot here forgot to set the airspeed. You can see LNAV, VNAV, auto throttle, disconnect like this, set back LNAV, auto throttle, flight director over here, autopilot engage and disengage like this. So we set only LNAV, the airspeed, set the airspeed, very important for after takeoff. I'm gonna set it. The heading, bank angle over here, and heading guidance. We set bank angle and heading. I'm gonna select 136 degrees, magnetic north pole heading. Orientation over here. Also the altitude, target altitude, thousands over here. Gonna set and hundreds. Also the vertical speed, you can set descent like this. You see the minus sign, it rolls down, and you can set climb. You see the plus sign again. We have also VOR localizer, Lszh localizer, and approach for auto land. So now we are ready for takeoff. So stay with me until the end part of the video. We're gonna be flying the aircraft here. So you will see the complete flight from takeoff, climb, cruise, descent, approach, and landing. So parking brakes off. Over here, advance the thrust levers, flaps also, set for takeoff. So we take the clearance from the air traffic control and we align the aircraft with the runway, heading over here. So we advance only thrust levers to maximum takeoff thrust, as you can see, and we align only bit of the runway, center line is in the tiller and the rudder pedals above for 70 knots. So we have 60 knots, 70, 80 knots, as you can see. Keep rolling, 100 knots, pressurize a little bit. Now we have the V1, we rotate, pitch up 9 degrees, and we wait for a couple of seconds, and the aircraft is becoming airborne, as you can see, and pitch up a little bit the horizontal trim stabilizer. So we have the takeoff, as you can see. Use a little bit more thrust. So we have positive rate of climb, landing gear, retract, as you can see. So we are 1380 above the ground, as you can see. You can see the terrain also, the indications, the engines, very beautiful. The airspeed 195 knots, the stall speed here, the pitch altitude, called the pitch altitude, we are 2400 above the ground, but 4000 feet above the sea, climb with 5300 feet per minute. So you can see again the stall speed, the flaps indications, the engines over here. You can see the flight plan we have to follow over here, and the terrain. You can see in front flight plan, and below you can see how far above we are from the ground. So we need also to pay attention to the ground below you, this indication, because we might hit some mountain below you. We are 4000 feet approximately above the ground right now. We are very close to the stall speed. So you will see also the outside view of the aircraft as we climb over here. We have a beautiful view of the Switzerland, the lakes, the Swiss Alps. So we're gonna start the turn now as we are climbing. So you see the turn now, very easy turn actually, not quite a problem since this is not an old-fashioned aircraft, new design, fly-by-wire. You know, fly-by-wire means if you fly the Airbus aircraft also alongside with the Boeing, so it's pretty much the same quality. So gonna level off the wings. We don't need to turn. You can see also maybe a little bit right turn now. We can hands off the aircraft, there is no problem. When you fly, you can leave the hands off if you are properly trimmed the aircraft. So we keep climbing over here. Change the mode here, the ladder. See also the flight plan again as we climb. And we have 14 more minutes for this flight. As you can see, you can leave the hands off the flight controls as we fly. You can see, you can do that sometimes, from time to time. So this is the view of the aircraft after takeoff, as you can see, the cockpit. The head-up display, what it displays, autopilot, flight director system panel, engines, indication, flight management computer here, engines, very important. And the indications, we have the first waypoint here, desert, then Zui, and to follow the Zui over here after. The flight plan, you can see the stall speed, 159 knots is the airspeed, 160, the wind over here, 269 degrees, bearing on 33 knots right now. You can see also the wind here, the ground speed, some other indications, the terrain around you. So we need to make a small turn over here. So we have a beautiful view of the Boeing 787, as you can see. You can see we also have here to hold the waypoint as we're flying. We have the Switzerland here, as you can see. Beautiful view. The Germany, Bayern Munich, my homeland. In front of you, gonna be flying over the lake also in France. So we need to align with the center line here, with this flight plan line, the purple. So we have 12 more minutes left for this flight. Hope you enjoyed the Boeing 787. Full manual flight right now. We're flying with hands flight controls. You can leave the hands off, you can see, and the aircraft keeps flying the way we want without touching the flight controls. It's pretty much safe and well trimmed, as you can see, without the autopilot connected. So you do only with an aircraft when you are in a good trim. Also here you can see, keep climbing, 19,000. You see the waypoints we have to be flying through. A line here also. And we have 11 more minutes, as you can see. We're gonna be flying over the lake here. The France, the Italy, on this side, Switzerland, the Swiss Alps, the lake, beautiful lake, and Germany, my homeland, Bayern Munich. So we're flying around 30,000 feet, 500. We need to start out the turn now, I believe, to go back into the airport. So we make the turn here, as you can see. You can level off, you can move the aircraft like this. You will level off quite fast, quite easy. You can see how fast it turns. You can use a little bit right rudder for the turn. And we have 10 more minutes left for this flight. Keep climbing. So we take the turn here over the lake. We're flying the lake. We have 10 more minutes for the video to end. The galaxy, beautiful view, the lake, and the Boeing 787, the Swiss Alps also. So we need to align faster, also use a little bit more right rudder as we turn. Make a faster turn, keep climbing also. So we're leveling off again at 23,000 feet. Again, we can hands off the flight controls, as you see, there's no problem. The aircraft keeps flying because it's trained properly, and we have enough thrust from the engines. We are here, flying at this altitude. So we're gonna be having the chemtrails couple of seconds. Also need to make some small turn here. You can see also the view of the cockpit as we are flying at this altitude. Keep flying manually, you can see. So we have the chemtrails now, very beautiful view indication of the frozen vapors, 24,000 feet. Again, the Germany, the lake, the France, and the galactic view also. can see, we're flying 34,700, 35,000 feet with a very high airspeed. So we have these frozen vapors from the aircraft. Hope you like this view of the Boeing 787. We keep climbing, and we're gonna start coming for a descent to the airport. So we have about 7 more minutes left. With the level off here, 36,000 feet. Speed brakes and flaps also retracted. And we start the descent now to the airport. We have 7 more minutes. So this is the descent now, back to the airport. So keep descending. Also nice view again of the cockpit over here as we descend. We have the airport over here. You can see the lights, and also start the turn now. You can see we have to follow these waypoints here as we're flying. So we start the descent again. 5 more minutes left. You can see we are descending right now. And we have 5 more minutes. This is a little bit more idle thrust over here, and trim down the horizontal tail of the aircraft. You can see both sides that we follow correctly over here. The flight plan, we need to start the turn now over here for the approach, terminal approach. Start the turn now and descending. Keep descending. And we have 4 more minutes left for the flight. As you can see, we are approaching full landing. We need to descend a little bit lower as we are approaching. Leveling off, and may take another turn now. It's a little bit left rather, as you can see. So we are 7,000. We need to descend a little bit lower, as you can see. The approach, arrival and approach over here. So we need to hold here, make a little bit of small turn. We cross through all the clouds, as you can see, and we have the runway here we need to follow. the line over here as we approach. Landing gear down, flaps also extended over here, and we have 2 more minutes left for the approach and landing. 2 more minutes. So we see here gonna be having a nicer view over here for the approach and landing view. As you can see, the aircraft is set up for approach and landing right now. We have also the Lszh localizer here. We are aligned with the Lszh localizer information, but we need to have a little bit more power thrust over here, and we have 1 more minute left for approach and landing, so we need a little bit more airspeed. You can see we are approaching for the landing. So we have a little bit side wind and some wind gust. This makes more difficult the alignment. We need to use the rudder pedals also as we are approaching for landing. We need to combat the side wind. We need to maneuver for a line with the center line. Use a little bit more or less thrust from time to time also. Manual thrust and manual flight controls. And we are very close for the flare of the aircraft. We align and we have over here the flare, as you can see. So we flare, beautiful flare, beautiful touchdown, parking brakes, idle thrust and thrust reverse over here for the aircraft to slow down in the runway. As you can see, we have a few more seconds to slow down, align with the center line with the rudder pedals. So you can see we're slowing down over here. We have a few more seconds. You can see all the landing gear parts over here are safe. We just landed. So you can see all the parts of the nose wheel are perfectly safe.